Oh, apparently it started now on mine. On yours, I don't know. Anyway, okay, whatever. Okay, hi everyone. Welcome to the IEA Wind Task 43 Metadata Challenge webinar series number 3. I'm not going to try and pronounce Magdalena's full name. Maybe she can do it herself in a minute. But anyway, Magdalena from the Gdańsk University of Technology is here, so welcome. I love the title of this talk today, One Size Does Not Fit All, Challenges and Barriers in Creating the Bridge of Knowledge repository for sharing data. So we'll, as usual, for you regulars, you know, I'll do a quick welcome and introduction. Then Magdalena's going to talk for approximately 20 minutes. Don't worry too much about being exact. And then we have time for Q&A, and then we'll try to do a summary. Every time I notice there's an error on this time plan, and every time I forget to change it. Anyway, hopefully we can define something that we want to do together in the future, together with IEA Task 43. Yeah, so just for those of you who don't know, IEA Wind Task 43 is part of this thing called the IEA Wind Technology Collaboration Program. There's many tasks. There isn't 43 tasks, but it's because the numbers, when people extend the task, sometimes they get a new number, and so but there aren't 43 running parallel. And the task 43 is about digitalization. Website's here. And the metadata challenge is part of work package 2, which is to do with data standards and sharing. And what we're trying to do in the metadata challenge is to research into metadata and knowledge engineering, but also increasingly anything to do with fair data for wind energy applications, and then use the results to develop recommendations for the sector. So in sub-challenge A, we look at managing metadata and schema. In B, we look at defining schema. In C, we look at existing things that are going on. And in D, we look at, well, it says politics, but more is meant like the dissemination part. And so as part of this, we recently started this public webinar series, and we're trying to improve the collaboration between knowledge engineering and fair data experts and domain experts in the area of wind energy. So we learn from each other. Why is knowledge engineering important? Well, the successful digitalization of the wind energy sector is one of the key drivers to reducing costs and risks over the whole life cycle. There are many opportunities, including digital twins, predictive maintenance, drones, AI systems. And these can all contribute to reducing the costs of energy and increasing the amount of energy. And we don't just need physics and simulations and data analytics for these solutions. We also need AI systems to process, interpret, and perform logical operations on structured data. And then we need this structured data in the first place that represents the information that can be used by these systems. And what do we mean by improving our understanding of knowledge engineering? Well, the first thing is to sort of get a grip of all these terms that are often thrown around. So metadata, taxonomy, ontology, etc. We've actually recently launched a glossary, which is an ongoing thing, which can be improved at all times. But we also want to work out, like, what do we actually need to know? What has been done so far? What can we learn from experts in the knowledge engineering area? What can we learn from other domains? How can they learn from us? Because wind energy is quite a challenging application, I think. And then how can we work together? So to the topic that we're going to hear about today, publishing and sharing multidisciplinary scientific data. Why is that interesting or important? Just generally, data sharing encourages, well, it's good because it encourages more collaboration between researchers. This can result in important new findings and innovations. It's efficient because it allows people and researchers to share resources. It generates more robust data and analytics, and it can help customers generate ideas or companies generate new ideas or learn new ways to process data. And it can in general bring more intellectual power in people from different disciplines and different perspectives together. But it also generates some fear and resistance. It creates legal issues that need to be solved. It opens up certain vulnerabilities. and it challenges the norm. And so what we're going to hear about today is an example of a new thing that's been developed, and I think we're going to hear about some of the challenges with doing this. So I'm really excited to hear what you're going to say to us, specifically because we have planned a project together and hope that works out. So I will pass over to you.
Thank you very much, Sarah. I will try to my presentation. I hope you can see it. Let's say now.
By the way, the recording isn't working, Yuri. I don't know whether you can try again. Sorry. All those amazing things I just said didn't get recorded.
I think it is still recording on my end. So.
Okay. All right, go for it.
Okay, it's working.
Yeah.
Okay, so once again, Sarah, thank you for inviting me for this webinar, and I hope I will show you a little bit different approach than from your previous and next webinars, because I'm not from your discipline. I'm not an expert. I'm working at maybe a few words about me. So my name is Magdalena. I have two surnames. Szuflita is my family name, and Żurawska is after my husband. And sometimes I don't know why I agree for the second surname because it's a little bit complicated. However, I'm working at the Gdańsk University of Technology library. I'm head of the section of scientific scientific and technical information, and I'm also a head of the Open Science Competency Center. And I'm also the data repository manager. And my actually discipline, because I'm a PhD candidate, is economics and management, and I'm working on research productivity and bibliometric and scientometrics. And today I would like to show you and to share with you some experience and views about our second project, breach of data. But actually the history, the roots, they are in 2016 when we get funding for establishing and develop the breach of knowledge platform. Because what is quite unique in our infrastructure is that we have a quite big platform with different services and different models. So the model of data repositories is just the one of the few repositories, because at the beginning in 2016, we started with the open access. So we started to build the platform and also the repository for publications. And about also, of course, different services for researchers. And the second project in 2018 it was finished last year in June. This project was based on the breach of knowledge platform, but it was like a second stage, and it's strictly connected to the research data. So from the technical perspective, the breach of knowledge as a platform, I will show you the platform at the end probably. integrates different system, and regarding data, integrates multidisciplinary and also multi-dimensional data from many databases. Our metadata at the moment describes each piece of data, and also it's of course is connected to other objects and machine to understand the metadata format. For example, in terms of linking, because that's it works somehow as a CRIS system at the university. We are able to connect each object, such as data, publications, equipment, tools, laboratories, even lectures and scientific profiles in one places. And that's the reason our services are dedicated mostly to sharing information between researchers, to accelerate the collaboration between our researchers and different other communities, and also they have the potential for evaluation and metrics evaluation. So some technical features about our platform. First of all is our solution developed by Gdańsk University of Technology. It was like because it was a project and we couldn't in Poland. I'm not sure how is in your countries, but many projects regarding developing the infrastructure, they in their assumption is that you have to develop your own infrastructure. For example, you couldn't adjust some of the existent software or infrastructure to your domain or to your assumption. You have to develop the infrastructure by yourself. That's the reason all the software, all the solutions, they are developed by our IT teams, and also 2 IT teams from central. How they call it? 2 IT teams. One is from the, let's say, internal, and the second one is from 3City Academic Supercomputer Task department. So we use, of course, open source technologies and components, and it's based on the Elasticsearch indexing and search engine. Metadata and data are located in an SQL database. I will show you the diagram on the next slide. And this database, of course, provides object storage, which is compatible with different standards. So that part is located in 2 private clouds. So the first one, the main engine, works in this IT services center cloud. So it's based in the entire university. And the second one is exactly located in the Task. And in Task also, we have one of the biggest supercomputers in Europe. Both clouds are managed by Kubernetes, and also the storage proxy, the authorization is based on the JSON Web Token. The second part I will show you later of our repository, which we couldn't exactly that I will show you later about our problems, and you will see that one of the disciplines we couldn't really strictly connect to the to our databases. That was the medical data. And the DICOM pictures of different tissue and organs, and they are like now like a separate repository. We call it digital pathology. And this digital pathology uses exactly the image server, especially the DICOM file server. So that's the picture or the schema of our architecture and platform. And at the moment, in the Task Cloud, we have over 150 terabytes of this DICOM images. And on the other hand, we have storage for our data sets from other disciplines, and they are stored in the IT cloud. So we have two clouds at the moment. So at the beginning of our project, we started to think what we would like to achieve. That of course we have repository for publication, and that simply works for all. However, when we started our project with two other universities, Medical University of Gdańsk and University of Gdańsk, and we are Polytechnic. We realized that we have so many disciplines which would like to use this repository. So first of all, we started to think why researchers would want share their data. And unfortunately, in many cases, we realize that they do not want. They just don't want share data. They must share their data. And beyond all the challenges with description, with metadata, and so on, we realize that many funding and grant agencies they also have requirements for data repository, which, for example, couldn't be fulfilled by subject repository, which are already exist. One of the example is quite new, is Plan S, which is developed by Science Europe and signed by many national science agencies, which accept the data management plans and data management plans, which is necessary for all the grant applications. They also issue requirements for data repository, which could be used exactly in those grantees. Sarah, for example, applied for a HIST-ERA grant. And I don't know if you know that if you will be success, it will be not so easy to choose the right repository to store your data or to share your data from the HIST-ERA project. However, the bridge of knowledge will be ready for that, because, for example, we just finished. Almost finish, for example, the certification process to be a trusted repository and get a certification of Core Trust seal. Another examples, for a data repository is that you have to, let's say, give acceptable persistent identifier, which some of the subject repositories they are also, they don't give acceptable by, for example, European Commission European Commission do not recognize the persistent identifier. And the second, it's what's quite easy, because some of the researchers they really want to share their data. Because, for example, they would like to foster new collaboration, they want to increase data circulation between or in their discipline, transparency and reproducibility. However, in many cases, in that situation, they prefer to use the subject repository, where they operate for a specific metadata standard. However, we wanted to also to check what kind of requirements we supposed to fulfill when we in the middle of developing our repository to let's say try to convince them to put data to the breach of knowledge. And the second thing, the third thing, or I don't know how many things, it was the suggestions from our researchers. That they also would like to have a data repository which gives them recognition. And by the recognition, they understood for example, the citations, data citations, and also the indexation. And indexation, they wanted to put data in repository, for example, index by data citation index from Web of Science, which is connected to the scientific evaluation. When, for example, maybe in the next scientific evaluation, they want to they have to report the number of data sets created. So that's only a few examples which we had to take into consideration before we even start to build our repository. So actually, that part it was like a nightmare, because to put everything, all those requirements, suggestions, and opinion, because all the researchers which were working in our groups, they have their own opinion, to put together and try to create, design and develop something. It was actually really time consuming. So here you can see our flow chart of the entire process of the breach of data repository and the implementation. And basically we focus on the three parts. The first one, it was building a team. The second, analysis, and the third one, develop. So we had to establish the scientific teams from almost all the scientific disciplines which appeared at those three universities. So frankly speaking, I forgot to check, but it was like about 40 different disciplines. 40. So from technical engineering through automatic electrical, social science like economy, civil engineering, architecture, biology, medicine, pharmacy, and so on and so on. So many different disciplines, and together our scientific team, I think it was something like about 70 researchers. Then in the 70 70, yeah. And all of them, they have their own opinion, requirements, and so on. Then we, at the same time, we developed the competency center, which I'm the leader. So my main task was, of course, collecting information, communication with them, verification of the standards and recommendations, and of course providing trainings, because I'm also, let's say, somehow a specialist from open science, for example, from licensing and this, let's say, administrative side of open science. And then we developed two IT teams, specialist teams, for IT support, hardware, infrastructure, implementing, of course, interfaces, schema, and different protocols. The second step, it was analysis. So we collected data from different scientific disciplines, and we analyzed all the data, data sets, and we try to, let's say, make something like an inventory, what kind of data they produce, what different requirements they have. And we very easily, we started to realize that different disciplines, they need different approach. Some of the disciplines, they have, for example, problems with legal requirements for sharing data from IT, from informatics, information science. When they produce, let's say, software code and databases, they didn't, and they usually use GitHub. So for everything. So, and it was really sometimes try to hard realize what kind of recommendations or requirements from legal point of view they want to achieve. Then we have to verify existing metadata standards. We started to making the comparison of existing metadata standards, and we try to make or decide for some of the common metadata attributes. And I think I have it on the next few slides, that we at the end we compare Dublin Core, Inspire, and DDI. We strongly focus on DDI because it was recommended by Harvard University and their repository based on the dataverse. Sorry. However, at the end, DDI it was completely a mistake for our researchers. And then we also provide external services. For example, we hired a few lawyers to explain the legal requirements. We try to also hire few schemas and metadata standards specialists. However, they were on that part they strongly focus on DDI, which at the end was not success for our repositories. And also we started to produce the very big report for the formal and technical requirements to achieve all those standards recommended by European Commission, Science Europe, and other national funding agencies. So, and the step third, the develop. We at the end we were quite successful because we developed our universal metadata schema standards, and it's mostly based on the data side. However, we adjust this with few attributes or special requirements for, let's say, a discipline such as biology or our chemistry engineering, and so on. However, on that point, we realized that data from Gdańsk University, the Gdańsk Medical University, this metadata schema, those attributes, they are not enough, and they just need a completely different approach. And on that time, we realized that we need to develop two things. The first thing is like this open research data repository, multidisciplinary. However, this it can't be treated as a subject repository. And the second thing is digital pathology. This is especially for this medical data, this DICOM images of organs and tissues. Then, of course, we work on the user-friendly interface, and also we started to implementations Open API, open protocols, and in-house open and in-house metadata schema. Turning a little bit now to this metadata schema process, we divided this into the two stages. The first one, we selected the primary metadata attributes, which are consist for most of the scientific domains, not all of them, because we are still, for example, we didn't know what to do with geolocalization data. For it might we might develop some adjustment during the project now. We also selected few repositories and engines to be indexing, and we started process for indexation in Web of Science data citation index. The second stage consists of extending the metadata schema with the specific attributes. For example, this geolocation data, it will be in the future. However, we, for example, added information about ethical papers. And this information, this attribute about ethical papers, it was strongly recommended by our chemistry discipline. We also verify mandatory requirements from DataSite, Refridata, OpenAir, and Google dataset search engine. And the second part of the development, the second level of metadata as vocabularies or ontologies. Unfortunately, it needs to be developed in the next, implement in the next phase, because we just didn't have time to do this. A little bit about metadata. At the moment, the breach of knowledge dataset upload form requires a minimum, let's say, a minimum scope of data. that the author needs to provide. It's about 11 attributes somehow. Sometimes it's 13, sometimes it might be 8 or 9. Of course, the identification identifiers, they are based on ORCID for a researcher or for ROR for the institution. We try to present data on the website in the user-friendly and transparent form, which meet all the required standards, and also the description. It was decided to describe data in JSON LD format based on the schema org. And we hope that this method of description increase our indexation rate. It's working quite good, for example, in Web of Science and in Google and in referee data and the data site. However, still we have problem with Google data search. Okay, so what else? Data searching and binding. So all data gathered from the platform is organized as connected object according to RDF standards. It doesn't really matter how user gets to the resources, because we provide access by internal or external search engine. We have direct link, and we have also index data in internal and external catalog. Our approach to data organization makes it compliant with the 5-star open data standard. And here, basically, you can see our organization of data at our platform. And if I can move for one moment to the website. So it's available in two languages. So this is the whole platform, the bridge of knowledge. So you can see that we connected different services, and here are the tabs with our repositories. So the last one is Open Research Data Repository. However, we have also this digital pathology. It works like a virtual microscope, and this is the repository for DICOM images for those organs. So I'm not sure. We can take the skin and you can see all those DICOM. I hope the connection is quite fast. So you can see all those organs and all the DICOMs. The description was wrote by pathologists, the doctors from Gdańsk University, the medical university of Gdańsk. And here you can see this metadata. On the other hand, our Open Research Data Repository. This is example of the data set which I found by the keyword wind energy, but I'm not really sure if it's in your domain or not. I just take a simple keywords searching. So you can see that it's the author's description of the data. You can download, you can have the content preview, but unfortunately it's working only to the first 50 files at the moment. However, this data set contains just 37. You can see the information about license, year of publication, verification, creation date, language, fields of science. This is especially for Polish researchers, because maybe the data sets will be needed for the evaluation, and our evaluation of the scientific units is based on the specific discipline. So we just need to put that kind of information. At the moment we have DOI. I know that it's not the best option for the data sets. However, now it was decided to assign DOI. Then we have information about funding, because I told you that most of those data sets, they are from the grants, different grants applications. So we have we connected information about grants. Then you have keywords and information about citations. If of course, if the data set is connected, or maybe it is underlying data for any publication, we can also connect. We can also connect or linked publications or other objects, objects from our repository, like research teams, research equipment, laboratories, and so on. And I know that I'm just running out of time. However, the last thing I wanted to show you the Web of Science, because actually for some of the researchers, the recognitions and that kind of databases, they are important. So we are part of the Web of Science, and at the moment we have over 3,600 data sets indexed by Web of Science. However, digital pathology as a subject or separate repository is not connected, is not indexed by Web of Science. And at the end, I just only would like to mention the project where you are here, and I met Sarah, let's say, here virtually. So in that project, now we will focus strongly on the 4 disciplines: civil engineering, economics, natural language processing, and architecture. And we will try to adjust our metadata schema for those disciplines. We are working now on this, for example, on the attribution of geolocalization. And second part of our project is preparing a repository for a IOSC, to be IOSC provider. And we don't know if we try to index for IOSC portal those 2 infrastructure, digital pathology and open research data repository, or just one. Okay, so thank you. So I know that it wasn't really technical presentation, and it's not in your domain. However, I hope I will give you some I don't know, some ideas, how hard is sometimes collaborate with so many disciplines.
Yeah, it's very interesting. Thank you. But even inside the wind energy industry itself, we get the same problem. I mean, wind energy is highly interdisciplinary, but you end up, okay, you don't have medical, but you have lots of different disciplines. So we kind of understand that problem as well. Who's got questions?
I'm gonna probably stop the recording so people are more comfortable asking questions.
Yeah. Now we can ask anything, stupid questions that we want.